Hello everyone, welcome back into today's video. In today's video we're going to be doing physical sciences, calculations on Newton's laws. These are the objects on the incline. Okay, yes, we're going to be looking at again objects on the incline as I introduced you in the previous video. Here we're going to be fundamentally calculating some complex questions, okay, yes, some tricky questions and so on. But it's easy, guys, you know. Please don't forget to subscribe, like and comment, whatever the case may be, but please don't forget to subscribe. Okay, just click that red subscribe button. Okay, yes, let's get into the topic. Okay, let's jump to the calculations without wasting no time, ladies and gents. Okay, so in this scenario here, we are given two blocks, okay, the 1 kg block connected with the 2 kg block in an incline, okay, yes, being pulled by 30 newtons, okay. This is the F, okay, this is the force, okay, force applied, I can say, pulling these two blocks upwards, 1 kg, 2 kg block. There is roughness, okay, in this inclined plane, okay, yes, which is the kinetic frictional force acting on the 1 kg block is 4 newtons, and the kinetic frictional force acting on the 2 kg block is 8 newtons. Okay, so the very first question says draw a labeled free body diagram acting on the 1 kg block. Okay, so let's go to our answers. So let me just write answers here. So number 1 for answers are 5.1.1. okay, let's say 5.1. so draw a body. Okay, so we're going to draw a free body diagram for this 1 kg block. Okay, so this represents the 1 kg block. Okay, free body diagram, all forces acting on it. Okay, so you can clearly see that this is the surface. Okay, this is the surface. Okay, this is the surface, meaning that the normal force acting there, it's going to be like this way. Okay, so this becomes a normal force. Okay, and so you know that the gravitational force is always acting downwards, straight downwards, okay, to the ground, to the earth's surface, I can say. So this becomes our gravitational force. Okay, so if ever this is our gravitational force, we know that this is our applied force, which is equal to 30 newtons, okay, up the incline, pulling this 1 kg block. Okay, this becomes force F, I can say, which is force applied. Let me say force applied, which is equal to 30 newtons, and there is a friction, guys. So if ever there is a friction, meaning that the frictional force is opposing the motion, the kinetic frictional force. Okay, this becomes the kinetic frictional force, and again we have on the very same side a tension force. Okay, tension force. Okay, the tension force of 2 kg block on 1 kg block. Okay, pulling it backwards. Okay, and the tension force. So that's how it goes for our free body diagram. For 5.1.1. so let's jump to 5.1.2. okay, so let's jump to 5.1.2. so 5.1.2 says state Newton's second law of motion in words. Okay, so stating Newton's second law of motion in words. Okay, you know, guys, again, let me re-emphasize this. You should, or it's a must for you to know Newton's laws, stating Newton's laws. Okay, Newton's first law, Newton's second law, and Newton's third law. You must be able to say them in words, okay? Because these are like 3 marks, guys. Come on, okay? So Newton's second law states that when the net force is applied on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of an object. Okay, so let me write it down for you. When the net force is being applied, the net force is applied on an object, okay, the object will accelerate in the direction, so sorry for double R, but direction, in direction of the net force, okay, yes, the acceleration is directly proportional to the net force, and inversely proportional to the mass of an object. Okay, that's how it goes for our 5.1.2 stating Newton's law, okay, Newton's second law. So when the net force is applied on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional, meaning that the acceleration like this, the acceleration is directly proportional to the net force, okay, to the net force, and inversely, and this acceleration is inversely proportional to the mass of an object, okay, yes, and that's how it goes. So when stating Newton's law, you have to write in full like this, guys. It's simple like it, okay, yes. I was just showing mathematical representation or in the shortcuts of showing how the acceleration is directly proportional to the net force and inversely proportional to the mass of an object. Just don't mind this one, okay, I'm just showing you. So just mind the definition. Okay, so let's jump to 1.3, 5.1.3. So calculate the magnitude of the tension in the string connected the blocks. Okay, now let's calculate the magnitude of the tension there. Okay, so in order for us to calculate the magnitude of the tension, let me give you this rule, guys. Okay, let me give you this rule. Okay, so my rule is when calculating, okay, or dealing with the objects that are moving on the incline, okay, or the objects that are being pulled, or the force that is being applied on an object is causing or is resulting in an angle, okay, yes, like forces acting on an angle. And here in this scenario, these are the objects on the incline, whereby the incline also is forming an angle. For instance, here is 28 degrees, okay, yes. So the rule that I want to tell you is that, please, in each and every time you begin to calculate, as we are going to calculate right now, first find the components. Here in objects moving on the incline, we're going to look for the gravitational components, okay? The force, the Fg components, okay? The force of gravity components, which is going to be a perpendicular component and a parallel component, okay? Yes. So let's start with 1 kg block, okay? Let's start with 1 kg block. 1 kg block. We are just going to draw for, okay, let me just write the components on a different paper. Okay, let's go. Okay, so I'm just going to write in this board, okay, the components there for the 1 kg block and the components for the 2 kg block. Okay, so let's start with the components for 1 kg. Let's start with 1 kg block. Okay, so for 1 kg block, so our components will be like this. Okay, let's start with free body diagram. Okay, always start with free body diagram when looking for the components, but others might know, okay, what are the components there, or the easiest way. The easiest way, the perpendicular, it's, you know that it's going to go with cos, so it's going to be Fg perpendicular is going to be equals to mg cos theta, cos 28, okay? But I'm just doing for all of you guys to make it sure that I accommodate all of you, and this is the easiest way, okay? Yes, that you must always apply. Okay, so in 1 kg block, there is a force, normal force acting there. Okay, this is a normal force. There is a gravitational force acting downwards. Gravitational force. The force applied. Force applied. We have the frictional force, and we have the tension force. Okay, tension force. So gravity is equals to weight. Okay, so in this case, there must be, okay, must be a force, okay, that must be perpendicular, okay, yes, it's perpendicular to the surface, okay, yes, which is going to be opposing the normal force and with the equal magnitude of the normal force, which is Fg perpendicular. So this is going to be our Fg perpendicular. This is our first component, okay, yes. Again, let me reassure you this, guys. Okay, yes. Look, so the parallel component is always acting downwards the incline, okay, acting downwards the incline, meaning that it's either, for me, I can put my, or I can illustrate my parallel component. I can say yes, my parallel component here, or horizontal component for this gravitational force here, okay, here, okay, because it's pushing the object to move down. It's gravitational force acting in this incline, okay. So, but now, since I want to make things easy for you and to be clear for you, what I'm going to show you is that, look, so we have also, okay, I'm just going to write Fg parallel here, okay, the gravitational force, the component that's acting parallel, okay, here, but it's also here, guys, but I'm drawing it here so that we can be able to work with theta and find our components, Fg parallel and Fg perpendicular, okay. I think you understand. Okay, so this is going to be our Fg parallel right now. So this is gravitational force, and this is let's say this is Fg parallel here. Ish, you can't say, I am pretty sure. Okay, let me just say like this. Okay, but you should know this is Fg parallel, this is Fg, okay, the gravitational force, Fg parallel, Fg perpendicular. Okay, so you know that this becomes our theta, And if ever this is our theta, meaning that this has formed a triangle here, this is going to be opposite side, this one, okay? This is going to be opposite side, and this is going to be hypotenuse side, this side of the gravitational force, and this side is going to be the adjacent side, okay? Yes, obviously it's going to be adjacent. So meaning that now we have to look for theta. This is our theta here, okay? Yes, this is our theta. If ever this is our theta, meaning that theta is being formed by which lines or which sides of this triangle? The hypotenuse side and the adjacent side. You know that in our trigonometric ratios we have things such as iso, ka, toa, okay? This is adjacent over hypotenuse between or forming this angle theta here. Adjacent meaning that we go with cos. So the adjacent, okay, adjacent over hypotenuse is going to be equal to what? Is equals to cos, okay? See, this is sine, this is cos, this is tangent, which is tan, okay? Yes, so they go with this one, so it's going to be cos theta. So our adjacent side, it's FG, okay, perpendicular, okay, as you can see, FG perpendicular, it's our adjacent side. Hypotenuse side, it's FG, the gravitational force, is equals to cos theta. So FG perpendicular is equals to what? FG perpendicular is equals to, because they cross multiplied, okay? FG multiply by 1, FG perpendicular, FG multiplied by cos theta. This becomes FG cos theta. And that's how it goes. That's how you get, or you can continue calculating your components, okay, in finding your component, etc. Okay, so this I can say is the formula to calculate for, or is the formula for FG perpendicular. Always it's like this, but I derived for you, okay? I derived for you to make things easier so you can see everything clear, okay? Yes. So let's continue. Okay, if we continue, we are going to have FG perpendicular is going to be equal to mg, okay, cos theta. By the way, it's this one, okay? Yes, but you know that FG gravitational force is equal to mg, mass times gravitational, okay, acceleration. Okay, so in that case, your FG perpendicular is equal to what? What's the mass of that object? It's 1 kg. It's 1 multiplied by 9,8, okay? Cos, what's theta there? It's 28 degrees, okay? Press on our calculators, guys. FG perpendicular is equal to, let's press on our calculators. Let's see. For 1 kg, it's 8,88 newtons. It's 8,88 newtons. So this becomes our gravitational force acting perpendicular, okay? Meaning that our gravitational force acting perpendicular is also equal to the normal force. Also, our normal force here is 8,88 newtons, okay? Yes. Gravitational acting perpendicular, okay? Yes. Okay. So we found the perpendicular component here, okay, on this 1 kg block. Now, what are we going to look for? Now we're going to look for the parallel component, okay? The gravitational force parallel component. Okay, so you can see that the gravitational parallel component is this one, okay? Yes, this one. So meaning that if I have FG parallel here, meaning that we have the hypotenuse on this side, obviously, so we have this angle here, okay? Yes, so we're going to look for theta, which is 90 minus theta here, okay? Yes, we're going to look for theta, meaning that we have the hypotenuse and the opposite side. The hypotenuse and the opposite side under sine, okay, under this trigonometric ratio, which is sine. So we are going to say the opposite over hypotenuse, okay? Opposite over hypotenuse is equals to what? It's equals to sine theta. It's equals to sine theta. Okay, so what's the opposite there? Opposite side, it's FG parallel over, what's the hypotenuse side? It's FG, the gravitational force, is equals to sine what? It's equals to sine theta. What's our sine theta? Our sine theta is sine 28 degrees, okay? Sine 28 degrees, okay? Yes, over 1. Okay, let's make it short like this. So let's cross multiply. We have FG parallel this side is equals to FG multiplied by sine theta, sine 28 degrees is equals to FG sine 28 degrees, okay? Yes, so and that's how it goes. So in this case, we are now going to say FG parallel is equals to mg, because you know what, FG is equals to mg, okay, minus multiplied by gravitational acceleration sine 28 degrees, okay. And now we have f g parallel, which is going to be equals to 1 multiplied by 9,8 sine 28 degrees. Please press on the calculator, guys. You press 1 multiplied by 9,8 sine 28 degrees, okay? Yes. FG parallel will be equals to, let's press. Okay. Okay, we have 4,60. 4,6, let me say. 4,6 newtons. And that's how it goes, okay? And this is this is the gravitational force that is acting parallel, okay? Yes, that's how it goes. Gravitational force acting parallel. Okay, so that's how it goes. Okay, so now let's look for the 2 kg block, okay? Let's look for the 2 kg block. Let me say that for 2 kg block. Okay, so for 2 kg block, let's first draw the free body diagram, so you know that this is the tension force that is pulling it upwards, and we have an opposing force, which is a frictional force acting there, the kinetic frictional force. We have normal force, okay, perpendicular to the ground, to the surface. We have the gravitational force acting downwards, okay. So now we're going to look for what? For the components of for the perpendicular component and the parallel component acting on that 2 kg block. So now we're going to have the perpendicular component, okay. This is the perpendicular component, gravitational force acting on that object there. I hope you can see. Yes, okay. So again, the parallel component is acting downwards, down the incline, okay. Yes, but I'm going to show it here so that you can form a triangle, so that you can understand everything. So now we're going to have the parallel, okay, FG parallel here, okay. Yes, so this becomes our FG parallel. So this is our gravitational force, and put it this side, okay. This is our gravitational force, original one, and these are our components forming a triangle here with this gravitational force. So you know that this side becomes the side of FG parallel becomes our opposite side. This side becomes our adjacent side, obviously, because we have theta here, okay. Yes, because theta, the side that is opposite theta, is the opposite side in a triangle, okay. Yes, in a right angle triangle, I can say. So because this is right angle here that is being formed by this perpendicular line bisecting this parallel line, you know that becomes 90 and the right angle. So hypotenuse this side. Okay, so now let's look for the components. So theta is between what? It's between hypotenuse and adjacent. So this is cos, okay? Yes. This hypotenuse over adjacent, over hypotenuse. Adjacent over hypotenuse, okay? Is equals to cos theta. What's the adjacent side there? Adjacent side FG perpendicular over the hypotenuse side, which is FG, is equals to cos what? Cos 28 degrees. Cos 28 degrees, sine. Ish. Oh no, why did I cancel that? This is very correct, okay? So sorry guys, sorry. So this is adjacent over hypotenuse, okay? Is equals to cos theta, and this becomes what the adjacent side there. The adjacent side there, it's FG perpendicular over what? Over FG. It's FG perpendicular over FG, okay? Yes, which is because it's the hypotenuse side, the FG is equals to cos 28 degrees. Let's waste no time, guys. So it's over 1. So we have FG perpendicular is equals to FG cos 28 degrees. So we have FG perpendicular is equals to mg cos 28 degrees, and this becomes FG perpendicular is equals to 2 multiplied by 9,8 cos 28 degrees. Okay, so therefore our FG perpendicular in this case is going to be equals to, press our calculator, F, okay, 2 multiplied by 9,8 cos 28 degrees, and that gives us 17,31 newtons. 17,31 newtons. So this becomes FG perpendicular. Okay, so we also have we have to find now the parallel component with FG parallel. Okay, yes. So it's sine now. Okay, you know that this is FG parallel, it's equals to mg sine theta, but let's derive it. Okay, let's go on from the get-go. Okay, so okay, so we're going to have the it's opposite over hypotenuse, which is sine. Okay, opposite over hypotenuse, which is sine theta. Okay, yes, we have opposite over hypotenuse, which is equals to sine theta. What is opposite side? Opposite side there is FG parallel over so hypotenuse over FG is equals to sine 28 degrees. So let's cross multiply. So this becomes FG parallel is equals to FG sine 28 degrees. FG parallel is equals to mg sine 28 degrees. So our FG parallel is going to be equals to, what's our mass? Mass there is 2 multiplied by 9,8 sine 28 degrees. Please quickly check in your calculators, guys. Therefore our FG parallel is equals to, so 2 multiplied by 9,8 sine 28 degrees, that becomes 9,2 newtons. 9,2 newtons. Okay, 9,2 newtons. Okay, so that's how it goes. I think you can see everything. So sorry for showing that one. I think you can see everything. Yes, so that's how it goes. That's how it goes. Okay, so these are our components. Okay, we found our perpendicular component for the 1 kg block, our parallel component for the 1 kg block, our perpendicular component for the 2 kg block, our parallel component for the 2 kg block. Okay, everything is going to be easy right now. Okay, now let's calculate this magnitude of the tension acting on the string. Okay, yes. Okay, so let me remove this. Okay, but please remember what is the, okay, let me just write them down. Okay, let me just write them down here. I know there's no need to write them down. Okay, let's just remember everything, guys. Okay, make it sure that you write them down. FG perpendicular, FG parallel of the 1 kg block, etc., so that you can, when substituting, you don't get lost. Okay, yes. Okay, let me remove this. Okay, so now they said calculate. So now they said calculate. I have to make it sure that you see, guys. Okay, things okay. Okay, so calculate the magnitude of the tension in the string connecting the blocks. So I have to calculate the magnitude of the tension, and mind you, the magnitude of the tension here is the same here and here. Okay, yes, between here and what, at 1 kg is the same as this one. Okay, yes. So now how we can calculate the magnitude of the tension, you know that we are going to say, what are we going to say? We're going to say F net is equals to MA. Okay, yes. Okay, yes. So the acceleration, the acceleration, so sorry, the acceleration is not given. Okay, yes, it's not given. The acceleration is not given, meaning that we have two unknown magnitudes. Okay, the tension, the magnitude of the tension, and magnitude of the acceleration of the two blocks. Okay, so meaning that we're going to have two equations. We're going to form two equations. So for the, okay, so this is number 3 for the 1 kg, for the 1 kg block, for the 1 kg block, the net force is equals to MA, so if ever the net force is equals to MA, so this becomes so this becomes for the 1 kg block. Okay, so you know all the forces acting on that 1 kg block. Okay, yes, mind you, we said it's the applied force, which is equals to 30. Okay, minus, okay, let's make things very, very short, guys, minus the F, okay, the frictional force, the kinetic frictional force, minus the tension force. Okay, yes, the tension force, again minus what, the gravitational that is acting parallel. Okay, yes, down the incline that is opposing also, minus FG parallel, this is equals to mass multiplied by the acceleration. Okay, so what's our applied force? It's 30 newtons minus what's our frictional force acting on 1 kg block? It's 4 newtons minus the FT we're looking for, minus the FG parallel. Our FG parallel, mind you, guys, okay, let me bring it back. This becomes our FG parallel in 1 kg block. For 1 kg block, FG parallel is 4,6 newtons. So let's substitute 4,6 minus 4,6 is equals to 1 multiplied by A. So let's use our calculator and say 30 minus 4 minus 4,6. 30 minus 4 minus 4,6, that gives us 21,4. 21,4 gives us 21,4, okay, minus FT is equals to 1A. Okay, and this becomes our very first equation. This becomes our very first equation there. Okay, so for our equation 2, what we are going to do, For equation 2, we're going to say for the 2 kg, for a 2 kg block, the net forces acting there on an object is equals to mass multiplied by the acceleration. Okay, so mass multiplied by the acceleration, and that becomes, what are all forces acting on that 2 kg block? Let me bring back. So all forces acting on that 2 kg block here, you can see here. So we have the tension force that is pulling upwards, and the opposing kinetic frictional force, and also the opposing gravitational parallel. Okay, yes. Okay, so we have the tension force. We can also look there. The tension force that is pulling it upwards, that is favoring the motion, which is going to be positive, minus the kinetic frictional force, minus Fg parallel, okay, is equals to 2 multiplied by A. What's our tension force? We don't know, we're looking for. Minus, what's our kinetic frictional for 2 kg block? It's 8 newtons, minus what's Fg parallel acting on the 2 kg block. I think you can see the importance of first finding the components, guys, the horizontal and vertical component, which is our gravitational perpendicular component and our gravitational parallel component. I think you can see the importance, okay, yes, of finding them. Okay, for a 2 kg block, so it's 9,2 newtons. It's 9,2 is equals to 2A. Okay, let's press on the calculator. Negative 8 minus 9,2. Negative 8 minus 9,2, that's negative 17,2. Ft minus 17,2 is equals to 2A, and that becomes our second equation. Okay, yes, that becomes our second equation. Okay, now we have to do what? And now we have to combine these two. Okay, so let me just draw a line here so that you can have a space. At least you have availability of space. So we're almost done. Okay, so we have to combine our very first equation with the second equation. Okay, yes. Okay, what's our very first equation? This is our very first equation, and this is going to be our second equation. This is going to be 21,4 minus the tension force is equals to 1A, and our equation 2, it's Ft minus 17,2 is equal to 2A. Okay, and now let's solve the problem. And here we're going to have 3A. Okay, 1A plus 2A, 3A, and we are going to cancel the tension force, because this one is positive, this one negative, cancel each other. So 21,4 minus 17,2. Let's press on the calculator. And that gives us 4,2, right? Yes, and that gives us 4,2. So we're going to have 4,2 this side. 4,2 is equal to 3A over 3 over 3. Okay, yes. So this cancels this, and then we left with A. Then our acceleration is equal to what? 4,2 divided by 3. Press on calculator again. That gives us 1,4 meters per second, okay, squared, okay, 1,4 meters per second squared. Okay, so we find our acceleration. It's easy now for us to find out the tension force. You either have to substitute the value of A on the second equation or on the very first equation, but let's use the second equation. Let's substitute the value of A so that you can find our tension forces. You can see if ever we substitute our A there, the only magnitude that is going to be left or unknown is going to be Ft, the tension force. So after substituting A, we're going to find the tension force. So let's say substitute the acceleration where in equation 2, okay, yes, so we're going to have Ft minus 17,2 is equals to 2A. So Ft minus 17,2 is equal to 2 multiplied by what? By 1.4. So let's multiply 2 multiplied by 1.4, and that gives us 2,8. That is equal to 2,8. I hope you can see, guys. Yes, everyone can see. Okay, let's give us 2,8 this side. So this side we're left with Ft minus 17,2. 17,2. Okay, let's take 17,2 to that side. Let's say 2,8 plus 17,2. So therefore our tension force will be equal to, press on your calculator, 17,2 plus 2,8, or 2,8 plus 17,2 will give us 20 newtons. It gives us 20 newtons. So our tension force there is 20 newtons, and that's how it goes. Let's look at the following example. Okay, please hold on, guys. Okay, so there is this question here, guys. Okay, so the two blocks are interchanged so that the same 30 force, okay, 10 newtons force is now acting on the 2 kg block along the inclined plane as shown in the diagram below. Okay, so now these two boxes are being interchanged, okay, meaning that the 2 kg block is the one that is being pulled by the 30 newtons, okay, and the 1 kg it's on the behind. Okay, it's like that now. So the question is says 5.4.1, 5.1.4, how the acceleration of the system change. Is the acceleration of the system will change? No, meaning that you have to choose from increase, decrease, or remain the same, meaning that it will remain the same. The acceleration will remain the same, meaning that the acceleration will remain the same. Why? If maybe some of you don't understand why it will remain the same. It's going to remain the same because, look, mind you, what I told you before in the very first early stages of our Newton's law videos, I told you that a connected system, the acceleration is always the same. When a connected system moves, the acceleration of all of the blocks are always the same, okay? Yes, so meaning that in this instance the acceleration of the system will not change even if we take that 2 kg block to be up front pulling that 1 kg, nothing will change as long as our masses are not changed, okay? That's how it goes. So 5.1.5 okay says, how will the tension in the string connecting the two blocks change? Is the tension going to change? Yes, the tension is going to change. So let's choose, is it the tension is going to increase, decrease, or remain the same? It is going to what? It is going to decrease, right? How will the tension of the string connecting the blocks change? It's going to decrease, right? Yes, it's going to decrease. The tension is going to decrease, meaning that decrease is correct. Why I'm saying decrease? Maybe some of you don't get it. Look, in that case, that 1 kg block, you can see that it's smaller than the mass of that 2 kg block that is pulling, meaning that 2 kg block, if ever there is a bigger force, meaning that, there is a bigger mass, meaning that there's also a bigger force that is going to be applied there. Okay, meaning that 1 kg block is pulling with high, very high force. Okay, that 2 kg block. But in this instance, this 2 kg block is bigger than this 1 kg block, and this 2 kg block is like pulling it with less tension now. Okay, yes, meaning that the tension here is less. Okay, because this 2 kg block, this 1 kg block is pulling back that 2 kg block, but it keeps on moving forward. Okay, meaning that that's how it goes. And in this instance, this 2 kg block, this 1 kg block is pulling this 2 kg block, is pulling something bigger than it, meaning that the tension force that is being used there, it's bigger. Okay, yes, it's bigger, but here is less, meaning that the tension force is decreased, and that's how it goes. I think you get it. Yes. Lesson video. Okay, so as you can see in the diagram there, a trolley is freewheeling downwards at an inclined plane at constant speed of 5 meters per second. Remember what I used to tell you guys, or remember what I told you before, is that, or if ever you knew, if ever you see something that says constant speed, okay, whatever the speed might be, constant speed, again, whatever the speed might be, the acceleration is 0. Okay, if ever they told you about constant speed, you should know that, okay, in this instance, the acceleration is equals to 0. Done. Okay, yes. But now let's start with answering our number 1. Question 1 says, draw a free body diagram showing all forces acting on the 10 kg trolley. Okay, yes. Let's draw all the forces. Okay, so these are our answers. So these are answers for number 1. So for number 1, okay, so let's draw free body diagram. Okay, so this is the free body diagram. Okay, so this is the surface, so meaning that the normal force is going that way. This is the normal force, and this is the gravitational force. Okay, gravitational force, mind you, is always acting straight downwards. Okay, straight to the earth surface or to the ground, straight. Okay, yes. So we have what then? We have a frictional force. Okay, yes. So mind you, as you can see that in number 2 they said calculate coefficient of frictional, meaning that there's a frictional force. Okay, yes, meaning that the surface of the incline, it's rough. Okay, it's quite rough. And this is it. So this becomes a frictional force, kinetic frictional force, because it's moving. Okay, this becomes a kinetic frictional force. And okay, what pushes these objects to move downwards? It's the gravitational parallel. Okay, yes, it's that gravitational component that we are going to find when calculating in first, okay, in the very first stages of approaching our calculations. Okay, so this is the FG parallel. Okay, that pushes that trolley to run downwards. Okay, this is FG parallel. Okay, FG parallel, and that's your free body diagram for that 10 kg trolley. Okay, so now look, mind you, I said to you, when calculating or dealing with objects that are moving on the incline, in order for you to calculate effectively, okay, without making mistakes or without getting confused or without complications, you have to first find the vertical component and the horizontal component, whereby your vertical component it's going to be the gravitational force that's acting perpendicular to the surface, okay, or from the surface, I can say. So meaning that the gravitational force that is perpendicular to the surface, meaning that there is also with equal magnitude of the normal force, okay, yes, but opposite directions. And again, you have to look for these two components, the one that I showed you, the gravitational that is acting perpendicular, and also the gravitational that is acting parallel, its component, okay, yes. So in order for us to do that, okay, let's first find our components firstly, okay. So let me just come this side, okay, let me just come this side and draw another free body diagram so that we can work on through our components. So we said we have a normal force, we said we have a normal force, and we said we have a gravitational force that is acting downwards, okay, let's say gravitational force, and we have frictional force, and we have, okay, look, so in this side, let's say we have our FG perpendicular, our gravitational force, our perpendicular component, okay, our very first component. So this becomes our very first component, FG perpendicular. So let's say this is FG perpendicular, okay, yes. So now this is our FG perpendicular with equal magnitude of the normal force, they are equal, okay, that's why our object is not flying, okay. So again, we have what now? We have a parallel component, this one, but now let's not draw this parallel component. Oh, my pen is going to get dry. Let's not draw this parallel component here to make things easier and clearer for you, okay. But also there's no problem if we again draw it here, but I drawn this free body diagram again just to show you, to prove you something, okay, to make things very, very easy and clearer for you. So let's just draw our perpendicular, our parallel component here, okay, yes. So this becomes our parallel component, okay, this becomes our parallel component, which is also with the same direction as this one, as you can see, but now it's here, okay. And now I drawn this so that they can form a triangle, and you can see this triangle, okay, yes. And this is your 20, okay, passes through here, and this becomes your 20, right, yes, your 20 degrees, okay. If this is your 20 degrees, meaning that here this FG, okay, this gravitational force, it acts perpendicular to the ground, you know. So now it's a right angle here, okay, and this becomes a right angle triangle, meaning that if ever this is the right angle triangle, meaning that also in this side, okay, this one acted perpendicular, okay, it bisects this parallel line and it forms 90 degrees again, this triangle or on the other side, okay, yes. So we have theta here, okay, our theta is here, meaning that here is 90 minus theta, and our angle here is 90, meaning that we have theta here, as I told you before, okay. So theta is always here, just next to the dot, you should know, okay, yes, to make things easier. Okay, so we have theta here. What is the side in a right angle triangle, okay? Oh, I forgot to write down, so this becomes FG, yes, FG, and this becomes FG, FG parallel. Okay, this line, and this line is for FG. I forgot to write down FG parallel. Okay, yes, so this is FG parallel, this line that is moving the side, this one. Okay, yes, so which this side is going to be opposite side, because it's opposite in a right angle triangle. The side that is opposite to the theta, to angle theta, is an opposite side. So this is an opposite side. So if this is an opposite side, which side that is very, very close to theta and that is very, very long? It's the hypotenuse. Okay, and this side we have the hypotenuse, and obviously we have the adjacent side. Okay, yes, so the hypotenuse sides being long, adjacent being very close to theta. Okay, yes, so now in this case you can see that theta, angle theta, is between what? It's between the adjacent side and the hypotenuse side, whereby the adjacent side is being represented by FG perpendicular and the hypotenuse side being represented by the gravitational force. Okay, by the gravitational force that acted downwards. Okay, meaning that, okay, so angle theta is between adjacent and the hypotenuse. You know that we have SOHCAHTOA. Okay, whereby the sides that bisected and formed a special angle, that angle is going to be a specific trigonometric ratio. So when opposite side and hypotenuse side meet, they form the sine. Okay, so sine, so this is sine. Okay, this is sine, this is cos, this is tan. Okay, the tangent. Okay, so now opposite and hypotenuse give us sine, adjacent and the hypotenuse gives us cos, opposite and the adjacent give us tan. So my question is to you, angle theta is between what? Angle theta is between the opposite side, the adjacent side. Okay, angle theta is between the adjacent side and what? And the hypotenuse side, meaning is being formed by these two, adjacent and hypotenuse. So we have now here, hope you can see if I write there, we have adjacent over hypotenuse is equals to cos theta. Okay, so adjacent over hypotenuse is equals to cos theta. Okay, so adjacent side is FG perpendicular over, what's the hypotenuse side? The hypotenuse side, it's FG, is equals to cos what? Cos 20 degrees. Okay, cos 20 degrees. This angle is equals to that one. Okay, cos 20 degrees. So now I think you're with me, guys. I'm trying to explain by all means. I'm trying to explain myself as much as possible. Okay, now let's cross multiply. FG perpendicular multiplied by 1, that becomes FG perpendicular. Okay, so that becomes FG perpendicular is equals to FG multiplied by cos 20 degrees. That's because that becomes FG cos 20 degrees. So that becomes FG cos 20 degrees, meaning that our FG perpendicular is equals to FG perpendicular, FG and cos 20 degrees. So FG perpendicular is equals to mass multiplied by gravity. You know that FG, the gravitational force, is equal to the mass multiplied by gravitational acceleration. So cos 20 degrees. Okay, I think you're still with me, guys. Okay, so we have FG now perpendicular is equals to what? FG perpendicular is equals to, what's the mass of that object? It's 10 multiply by 9,8 cos 20 degrees. So let's multiply 10 multiplied by 9,8 cos 20 degrees. Let's press our calculators. 10 multiplied by 9,8 cos 20 degrees, that becomes 92,09. 92.09 newtons. So therefore our FG perpendicular, I hope you can see there. Yes, our FG perpendicular is equals to what? Is equals to 92, okay, 09 newtons. And that's how it goes. Okay. Yes. Okay, right now we found the answer of the very first component, which is FG perpendicular. Okay, let me re-emphasize this. Look, the only thing that you should know is that in each and every calculations, to make things short, is that you should know that FG perpendicular is always equal to mg cos theta. FG perpendicular is equal to FG cos theta, okay, whereby theta is going to be angle that is given in a specific scenario. Okay, I think you get me. So I am doing it to accommodate you all students, okay? Yes, to make it sure that you are in line with me, okay? Yes, because some don't know maybe why it's FG perpendicular is equal to mg cos theta. So now it makes understanding and it makes more to be interesting. I guess you get me. Okay, so now let's go and find FG parallel. This component, our last component. Okay, so FG parallel, you can see it's the opposite side. So our opposite side, okay, you can see it's moving that way, okay, to this angle. So it's between opposite and the hypotenuse. So which trigonometric ratio that is opposite and the hypotenuse? This opposite over hypotenuse. So this becomes opposite over hypotenuse, it's sine theta, okay? Opposite over opposite over hypotenuse. It's always like this, guys, in each and every scenario, but just do it for you, okay? Sine theta, it's called the sine theta. So opposite over hypotenuse, what's the opposite side? Opposite side, it's FG parallel, so sorry, it's FG parallel over hypotenuse. What's hypotenuse? It's FG. So this is equals to sine what? Sine 20 degrees, okay? Yes, sine 20 degrees over 1. Let's cross multiply. We have FG parallel, okay? Cross multiplying. FG parallel multiplied by 1, FG parallel is equals to FG multiplied by sine 20. It becomes FG sine 20 degrees, okay? And this becomes FG parallel is equals to mg, okay? You know that gravitational force is called mg. Sine what? 20 degrees, okay? Yes. So we're moving, okay? So let me draw a line here. I wish to be straight. Okay, so FG parallel is equals to mg sine theta. So we're moving, okay? I hope you can see up there. Yes, everyone can see there. Okay, so our FG parallel is equal to, what's mg? Our mg is 10, okay? 10 multiplied by 9,8 sine 20 degrees. Press on your calculator that, guys. Therefore our FG parallel is equal to, press that in your calculator. Let's press. So FG, okay, 10 multiplied by 9,8 multiplied by sine 28 degrees, 28. What's happening? I think that's 20. Yes. Okay, let me check. Yes, and that becomes on our calculators 33 33.52 newtons. I hope you received the same, guys. Okay, 33.52 newtons. So that's our FG parallel. What our FG parallel means? Our FG parallel means that the force that is pushing this object or this 10 kg block downwards, it's 33.52 newtons. Okay, and our FG perpendicular, the force that is acting this way, straight this way, because our gravitational force is acting this way, but the force that's acting this our gravitational perpendicular is equal to what? 92.09 newtons. Okay, hope you with me, guys. Okay, so the question says calculate the coefficient of the friction between the trolleys. Okay, look, just before we get to the question, there's something that I want to re-explain to you, to re-emphasize so that you don't forget anything. What I was going to tell you. Okay, what I was going to tell you is that okay, let me just say I forgot what I was going to tell you. Let me just say, oh, okay, I was going to tell you that here in this side of when finding FG parallel is that you should know in each and every instance or in each and every scenario whereby you have to calculate or deal with objects moving on the incline, you should know that the formula, okay, for FG parallel, for the gravitational force for this particular component, as I showed you in the perpendicular component, that it's going to be equal to FG perpendicular is going to mg cos theta. But in FG parallel, our FG parallel will be equal to FG sine theta. Okay, FG parallel is equal to FG sine theta. So theta will be the specific angle or the spatial angle that is there. Okay, yes. So I hope you get me. Okay, so it's easy like this, guys. So just find your components first, work on the side, find the components and work, because the components are going to affect your calculations all the time. It's very vital to find the components or to resolve that gravitational force, okay, into its components. Okay, I hope you with me, guys. So number two says calculate the coefficient of the frictional force between the trolley's wheels and the incline, meaning that there is a frictional force, a kinetic frictional force or a frictional force acting on that object 10 kg block moving downwards. Okay, it's opposing the motion as I showed in the Fibonacci diagram. Okay, so in order for us to calculate the frictional force, we're going to say the frictional force, the kinetic frictional force is equals to mu, okay, multiplied by the normal force. Okay, now look the importance of first finding your vertical components as well as your gravitational components, I can say. So look, so we have to find first, because we don't have frictional force. Our frictional force is not given. Our kinetic frictional force is not given. Our coefficient is the one that you are supposed to calculate, not given either. So only normal force that is going to be available there. How? Normal force is equal to what? Normal force is equal to this. It's not equal to gravity now, because you can see that they are in a different direction. Okay, it's going to be equal to the gravitational perpendicular. Okay, it's going to be equal to the perpendicular, okay, yes, component. So it's equal to FG perpendicular. So our normal force is equal to, what's our FG perpendicular? Our FG perpendicular is equal to 92.09 newtons. So our normal force is equal to 92.09 newtons. I hope with me, guys, right? Yes, hope you with me. Okay, look, now we are going to have F, okay, is equals to coefficient of the kinetic frictional force multiplied by 92.09. Okay, so now, okay, boom, we have nothing. Okay, we can continue, can't do anything. The only way now is to find the frictional force, okay, so that you can find the coefficient of the kinetic frictional force. Okay, so how to find the frictional force? We're going to say the net force is equals to ma. Okay, net force is equals to ma, the mass times acceleration. What are the net forces acting on that object? The net forces acting on that object is the gravitational, that is acting parallel, the gravitational component that is acting parallel, which is Fg, parallel, pushing it downwards. Okay, yes, to move downwards, to have a freewheeling. Okay, minus being opposed by this frictional force as shown here. Okay, yes, by this frictional force, by this Fk. So this is equals to, what is your mass? Your mass is 10 multiplied by the acceleration. What is your acceleration, guys? Your acceleration is moving, mind you, the trolley is moving at a constant speed, meaning that the acceleration is 0. Told you that, meaning that the acceleration is 0. So now let's substitute our Fg. Our Fg parallel is equals to 33,52. I think, guys, you can see the vital, okay, or the importance of first finding your components. Okay, 33,52 newtons minus kinetic frictional force is equals to 0. 10 multiplied by 0, it's 0. So, and therefore negative Fk is equals to kinetic frictional force is equals to, we take this that side, minus 33,52 newtons. So, and therefore your frictional force, your kinetic frictional force is equals to 33,52 what? Newtons. And that's how it goes. That's the end. Okay, you've done everything now, but not everything, by the way. What you have done now, it's only finding the frictional force. Okay, the frictional force is 33,52. okay, 33,52. I think that also you are going to substitute here. Okay, let's say there we have Fk is equals to mu k multiplied by 92,09, and that becomes, okay, Fk is equals to 33,52 is equals to 92,09 mu k. Okay, let's say mu k over 92,09 divided by 92,09. so this cancels this, we're left with mu k, our coefficient of the kinetic frictional force is equals to 33,52 divided by 92,09. Press on the calculator. 33,52 divided by 92,09, and that gives you 0,63. 0,63. That's how it goes. 0,63. Okay, done. Calculated everything, and that's how it goes. And that's the end of our lesson video for the day, guys. Thank you so much to those who have subscribed. Please, if ever you haven't subscribed, please subscribe. Okay, just click that red subscribe button. Thank you so much. I'll see you in the next following video. Cheers. Thank you so much.